All right, so let's go over the first discussion question. Um, so many of you included drawings that I saw, many of you did not. Drawings were not required. I just thought it might be helpful to kind of organize what you're thinking. I will try to give a verbal description of what I think this looks like while I am drawing a cross section of the container. But let's do this in sections. So I think this function can be split up into four pieces. So from 0 to 2, 2 to 4, 4 to 6, and 6 to 10. So what is going on in the first section? So the fact that I am seeing a straight line tells me that I have a constant rate of change from like of the height of the water with respect to the volume I'm pouring into it. So that suggests to me that basically first, the first millimeter of height here is going to be something with straight sides. So well, not as straight and vertical as I wanted, but that's okay. Um, Basically, there's a linear rate of change or a constant rate of change that tells me that um, my side walls need to be straight. So I think I can say the same thing for this next section, so from 2 to 4. But what I would need to point out is that I have a constant rate of change. I have a linear slope there, but it has gotten steeper. So I think for this next section, I'm going to still have vertical sidewalls, but actually, I'd take that back. Um, since I do have a steeper rate of increase, I'm going to have something like this. The interior walls are going to get like closer together because now, um, as I add, so I'm still adding 2 more cubic millimeters of volume, but I'm getting a more drastic increase in height. So from here to here, I believe that's 1 millimeter because it's the height. And then from here to here, I believe that's 2 millimeters. Okay, I believe I've handled the first two sections. What's going to happen in the next section? There's going to be, so I do not have a constant rate of change here. I have a rate of change that is constantly changing. So what does that tell us about the way this is going to increase? So at the very beginning of this next section, there is like the initial increase is very, very slight. Like it starts off like it even looks like it might be zero. So that leads me to believe that the height dramatically increases. So I'm going to start off, and as you're drawing this, you might wonder why anyone would want to drink out of something like this. And I have the same question. I think the height dramatically increases. That's why if you kind of imagine yourself as like a constant pour on this liquid, the height goes from increasing pretty steadily to immediately falling off. But and when I should be more precise. By falling off, I mean like going very near zero. But it starts to increase again. So what does that mean? I think that means since the increase of height with respect to volume, I think we have to have, you know, the increase is slight at first, but then starts to grow. Um, and then if we try to do something quantitative here, if I compare that slope right there to this slope right here, I think the slope here is even more drastic. So I'm going to draw these. I'm going to have these heights come even more, like these sidewalls come even closer together. So what was the difference in height there? Don't know how good of a job I am staying scaled, but that's okay. Another 2 millimeters of height there. Now, I think that's the first three sections. What happens with the next section? Looks like that rate of change is going to start decreasing again. So what does that mean? That means it's going to basically the height, the width of this container is going to start to start like basically the walls are going to start to spread out again. So can we be a little more specific about the way that's going to happen? So the rate of change starts off being steep for a bit, and then it starts to get shallower and shallower. So I think we are going to slowly work our way out toward, maybe not as steep as it was, but something like this. So as I finish this drawing, I am going to point out to you that if you did have a drawing, it most likely does not look like mine, and that's okay. And if you didn't have a drawing, as long as your verbal description is like plenty thorough, that's fine. Hopefully this description makes sense. Um, but one last note, this was meant to be something to get you all talking to each other, to get you all engaged, and to get you thinking about, the way quantities vary together. I do not think this is a simple question to answer or to think about, and that's very much intentional. So if you did have difficulty with it, don't sweat it. By far, the more important thing for me here is to see what you all take from each other's ideas. So yeah, thank you. If you have any questions, let me know.